good day everyone. My name is Jerlyn Soliguen of ECE 3A. So for today, I'm going to perform to you my performance task 3 in ECE 23 Communications 2. So what are the topics to be discussed? The topics to be discussed first is the pulse modulation, second is the pulse width modulation techniques, and lastly, some pulse method used in PWM. It talks all about NADD. So what is pulse modulation? In pulse modulation system, the unmodulated carrier is usually a series of regular recurrent pulses. Information is conveyed by modulating some parameter of the transmitted pulses such as amplitude, duration, time of occurrence, or shape of pulse. Modulation results in sampling baseband signals at regular intervals and converting the sample results into PAM, PWM, or PPM. So, pulse modulation is a type of modulation in which the signal is transmitted in the form of pulses. So, it can be used to transmit analog information, and in pulse modulation, continuous signals are sampled at regular intervals, varying the amplitude, polarity, presence or absence, duration, or occurrence in time of the pulses gives rise to the four basic forms of pulse modulation: the PCM, the PAM, the PWM, and PPM. So, there are two types of modulation, the continuous wave and the pulse modulation. But since today our topic is all about pulse modulation, so let's talk about the other side of these types of modulation. So pulse modulation has two types: the analog pulse modulation and digital modulation. In analog modulation, you can see here is the PAM, PWM, and PPM. While in digital modulation, you can see the pulse code modulation and adhesive delta modulation. So what is PWM? It is the time of occurrence of either the leading or trailing edge of each pulse is varied from unmodulated position by the samples of the modulating wave. PWM only requires synthesis of a few discrete output levels, which is easily realized by topologically simple high-efficiency switching power stages. On the other hand, the bandwidth requirements for PWM are higher than PAM. This penalty is well paid given the simplification in the switching power stage or the power supply. It is a powerful technique for controlling analog circuits with microcontroller digital outputs. PWM is used in many applications ranging from communication to power control and conversion. So you can see here is one of the samples that the PWM is commonly used to control these types of applications. So this figure shows the PWM signal. The on-off times are sometimes referred as the mark or the M, the space as the S here in the picture, times of the signal, respectively. Where we are interested in three parameters: signal amplitude, signal frequency, and the signal duty cycle. So what is the NADD? So NADD stands for natural sampling. Like you can see here, the sampling method, and you're gonna choose the edge, which is the edge is the double-sided. Next is the level, which is the AD, the 2-1, and you can see here is the NADD. So the meaning of it is natural sampling, AD switching, double-sided modulation. NADD modulates both leading and trailing edges of the pulses by using a triangle shape of reference. A simpler approach is the direct derivation from NADS by simple superposition. So you can see here the formula that will be used to solve the NADD. So you can see here, this is the four types the NADS, the NVDS, the NADD, and the NBDO. So this is the NADD, as you can see, where I go to circle it here. And you can see here that it it's shaped as a triangle, or you can say it as a triangular type of wave. And then this is the So the next is, it is the prerequisite for the above simple addition, that is that leading and trailing edge modulated waveforms do not overlap. This is obtained by a simple selection of parameters. Following by the trigonometric reduction mechanism, the series can be derived as, so you can see here is the another form of the formula that you can be used to solve the NADD. So the next is, what do you know more? If you want to know more all about NADD, so the argument to the Bessel function is half in comparison with both single-sided modulation schemes, NADS and NBDS. This is important since the ratio by which the IM components are reduced is increased considerably. This is of simple importance around the first harmonic of the switching frequency. Only IM components with M plus N odd are presented in the spectrum, meaning that about half of the HF spectrum, or the hybrid frequency spectrum, is eliminated in comparison to NADS. The stripe HES plot occurs. Similarly to NADS, NADD does not have a pleasant spectrum at low M, since the odd harmonics of the carrier are presented with maximal amplitude. From the modulation spectral characteristics, NADD must be concluded to be superior to NADS. Not as attractive as NBDS, mainly due to the characteristic at lower modulation index, the smaller skirts of NADD doesn't offset the advantage of the total elimination of the carrier components that happen at lower outputs level in NBDS. So this is the end. So thank you for watching, and thank you for listening.